Good evening. I'm Johanson, and I'm the director of the Institute for Human Origins at Arizona State University. IHO, founded in 1981 by our speaker tonight, is one of the preeminent institutions on human origins research. This institute and its researchers ask questions like where we come from, how we got here, and where we're going. We currently have about 17 research scientists who ask these questions from different disciplinary angles, and about fossil hominids and modern human cultural evolution, genetics, non-human primate behavioral ecology, and so forth. So this is like an interdisciplinary institute that has been doing research for the last 40 some odd years. In addition to groundbreaking and transformative research we do, we also invest in the training of graduate students, and we also invest a lot on science education and public outreach. So tonight's lecture is the second lecture in our Bill Kimbel Distinguished Lecture Series, which was set up 2 years ago in honor of Bill's immense research and mentoring legacy in the field of human origin science and his significant contributions to IHO. As many of you know, Bill was the director of IHO for many years, and his leadership positioned IHO as the leading institution in human origins research, and all of us at IHO were so devastated at his passing 2 years ago. In addition to the lecture series, we also started the Bill Kimbel Impact Endowment Fund to honor and continue his legacy in student training. This endowment will support graduate students who are interested in studying what Bill was really interested in pursuing in terms of his research. This endowment the success of this endowment fund is primarily dependent on support from all of you, and would ask that you consider supporting this program. You can contact me or any of the staff members of IHO if you're interested, or you can go to our website, IHO website, at iho.asu.edu. And a big thank you to everyone who has already donated to this fund. We are very grateful of your support to continue Bill's legacy and commitment to train the next generation of paleoanthropologists. I also want to take this opportunity to thank IHO's Executive Board, Research Council members, and Arizona State University for all their continued support of IHO. I want to also thank IHO research scientists, staff members, our national and international collaborators for their relentless effort to maintain the status of IHO as the leading institution of human origins research. Before I introduce our speaker tonight, Aaron Kimbel, the beloved son of Bill, would like to say a few words about his dad. So Aaron, could you please come to the podium? Thank you.
Hello. My name is Aaron Kimbel Sanet. I'm not Don, nor am I a scientist, but I am Bill's son, my dad's son. We are all here, as the title card suggests, because, and you'll allow me, even in the conservative city of Mesa, one curse, because of Bill fucking Kimbel, PhD. Beyond that, Lucy and Don, Lucy in particular, obviously is responsible for so much of why we're here, and not only from an evolutionary perspective, but why I know so many of you, and why my mom and I, neither of us are paleoanthropologists, why we know so many of you people. And Don also, from speaking Swedish with my mom or singing opera at the dinner table has been a huge part of our family as well. So I'm not going to say too much more. Knowing my dad, he would much rather be watching baseball than at this thing, as would I. But I just want to say thank you all for coming and for continuing to commemorate my father. And like I said, at his service, obviously he was an important person in my personal life, but I think we all recognize that Certainly his most visible contributions were to this field, and I think we all felt really proud of him for that. And yeah, happy you guys could all be here. So I don't want to stall any longer. I think without any further ado, I'll introduce Don Johanson.
Thank you, Aaron. Now, this is the hardest part of my job tonight, which is introducing our speaker. We have a very special speaker who will take us on one of the most important journeys of discovery in search of our earliest ancestors. A speaker who does not need any introduction because his name is a household name for those who have ever wondered, where do we come from? Our speaker this evening is none other than Professor Donald Johanson. As a scientist, I cannot overemphasize Dr. Johanson's contribution to science and the public's perception and understanding of human evolution. Over the course of his illustrious career, he produced one of the field's groundbreaking discoveries, the most widely known and thoroughly studied fossil find of the 20th century, the 1974 discovery of the 3.2 million-year-old hominin fossil in Ethiopia that added a crucial link to our understanding of our evolutionary journey. I'm, of course, talking about Lucy. Don will probably tell you what to read tonight before you go to bed. I'm going to leave that to him. I'm not going to tell you what to read. The discovery of Lucy completely rewrote our understanding of human evolution and prompted ongoing debates and major revisions to our knowledge of the human evolutionary past. As a matter of fact, 2024 marks the 50th anniversary of Lucy's discovery, and we've started celebrating Don and Lucy through various programs, including a day-long international symposium that will take place on Saturday at the Walton Center for Planetary Health Auditorium at ASU. In the years since Don earned his PhD at the University of Chicago, he has led field explorations in Ethiopia, Tanzania, and the Middle East, and effectively reached across multiple media platforms, hosting and narrating the Emmy-nominated PBS Nova series In Search of Human Origins, co-authoring 9 books, and lecturing at universities, corporations, and public forums to share his findings and stimulate healthy debate. What is really amazing about Don is his skill in communicating human origin science to the general public all over the world. How he connects the past to the present and the future in a way that is relevant to our society today. Driven by a notion we cannot fully grasp, who we are and where we are headed as a species until we have a more complete knowledge of our evolutionary roots, Don founded the Institute of Human Origins in 1981, which joined Arizona State University in 1997. He also serves as the Virginia M. Ullman Chair in Human Origins at Arizona State University, where he also teaches. Don is an honorary board member of the Explorers Club, a fellow of the Royal Geographical Society, and a distinguished member of the Siena Academy of Sciences in Italy. Without further ado, please join me in welcoming Professor Donald Johanson to the podium. Thank you. Thank you very much.
Johannes, thank you so much for that current introduction. It is such a pleasure to be here at this somewhat sad moment to remember Bill Kimbel, and I wanted to take a little time to tell you my own personal connection to Bill, which I still feel very strongly. He and I first met in 1974, so we are also celebrating those 50 years of his first being a student in my class back in Cleveland, then working together in various courses he took from me, traveling to Ethiopia with me in 1976 and catching the Africa bug, and felt that he wanted to dedicate his life to answering that important question that we all ask ourselves as children, probably the first one we ever ask, Mommy, where did I come from? And Bill really over the years evolved into a very major force in the field of, as we call it, paleoanthropology or human origin studies, and contributed enormous amount to our understanding of where we've come from. And it is a very, very special and a deep honor for me to have this opportunity to present the second lecture honoring Bill and remembering what a wonderful man and scholar he really was. Now I'm going to try to advance this. First of all, thank you all for coming and giving me the opportunity to speak in Mesa. You know, we up in Tempe sometimes think that we're the center of the universe. And it's wonderful to get down here and to, in this beautiful auditorium. I've spoken here before, and it is an extraordinary center. And National Geographic has brought many speakers here, and I was thrilled that we were able to arrange this evening for not only all of you, but particularly for me. Today is a fairly momentous day. Many of you know about that, certainly my colleagues in the audience, board members of the Institute of Human Origins, my wife, of course, who's sitting somewhere in the front row, and the staff of IHO. Science magazine, which is published by the American Association for the Advancement of Science, decided to honor really Lucy on her 50th birthday. And today, a article in a magazine was released, I guess embargoed till about 2 o'clock in the afternoon, and it was published, and the author, Ann Gibbons, of this feature story is with us tonight. And unbelievably, I mean, I am still stunned by this. I'll tell you, I get goosebumps when I show you the next slide. So I think she's maybe the first cover girl for Science magazine. It's amazing, 50 years, where does that go? And I try to convince people that I found her when I was 5. But if you read Ann's article, you'll find out in the last line that I've now turned 80 years old. So it's incredibly humbling to look back on all of those years and to the precise moment when my career was defined. I was 31 years old at that time. I had just finished my doctorate at the University of Chicago, and this January we traveled back to Ethiopia. Johanson came with us, my wife was there, some people in the audience, I believe, were also with us, and we went to the exact spot where Lucy made her first reappearance after 3.2 million years of being in sort of suspended animation. And it was a moment of great emotion for me to stand there and think that, you know, I was walking along, a young scholar, hoping to find something, and I realized that, you know, if I had looked to my left, I would have missed the first fragments of the skeleton. And fortunately, I looked to my right and recognized a little piece of arm bone. And that changed my life. It changed the trajectory of a lot of research in paleoanthropology. We have a symposium on Saturday, all day at the Institute, which is on the corner of Rural and University. And we will be hearing 20-minute papers about how their own research and the research area that they are most interested in had been influenced by the discovery that was made in 1974. So this is a very auspicious moment. This is the first time I have publicly shown this slide, and I'm proud to say that it was here this evening. We all know that there were wonderful scholars in the past, natural scientists, and you see two of the most important in my life. Charles Darwin, of course, is well known for his 1859 publication of The Origin of Species that caused such an uproar, a truly paradigm shift in the full sense of that word to understanding biological variation on this planet. He knew nothing about DNA. He knew very little about what we know about in terms of biology today. But he had a mind that was extraordinarily open, and he gathered evidence on his travels around the world and came up with the grand unifying theory of biology, which I call natural selection. And he had a great friend, a fellow named Thomas Henry Huxley on the left. And Huxley was very important to me because I read his book, which was published in the late 1800s, Man's Place in Nature, when I was a young teenager. And that was my epiphany, when I read that humans and African apes are closely related to one another and therefore must have had a common ancestor. And when I read that and the rest of the book, I felt that is what I want to do. I want to go out and find fossils that will help us understand how we became human. Chimpanzees, of course, Jane Goodall was just recently, as you know, in the Bay Area. She's 90 years old now, and she's been studying for chimps for most of her life. And we now know that chimpanzees are not just some kind of funny primate, that, but is a creature that is very closely related to us in terms of behavior. You see them termiting here in the lower left, sticking a wet twig or a piece of grass into a termite mound and getting those delicious insects out, very high in protein, saying that someday we'll all be eating fried insects. And on the right is a young chimpanzee just reaching up into those flying termites in sort of a state of awe. And they used very rudimentary tools. They use rocks to break open nuts that are very hard-shelled, and you can't break the shells, but you want to get the meat inside of them, and that's what we see in the top. And today we know from genetic studies that we are about 99% identical in terms of our DNA. And that identity, that shared identity, has to have come from a common ancestor. There's an incredible opportunity for people to travel and look at chimps in zoos or in Africa. This is a picture I saw at Jane's site at Gombe, and you really do feel some sort of a deep connection with them, even though we've been separated for something like 8 to 9 million years. So obviously, from what Darwin and Huxley said, and they recognized the great similarity in the skeletal systems, as you saw, one had to go to Africa to find these sorts of things. And this was a very bold assertion that was made by Darwin and Huxley, way back before many people even went to Africa. And this year we're celebrating also the 100th anniversary of the first discovery of a human ancestor in Africa, which was 1924, when this cheerful guy, Raymond Dart, was presented with an infant skull that he recognized as being very different from an ape, very different from a monkey, and that it had great similarities that suggested to him that this was an ancient human ancestor. He thought it walked upright, one of the cardinal features predicted by Darwin that makes us so unique. If you look at mammals around the world, there are very few, if any, except us, that walk full-time on 2 legs. And he noticed differences in the shape of the brain and so on and so forth. So this was the first discovery 100 years ago. And what's interesting about Raymond Dart was when I made the discovery in 1974, I was sitting in my office and my assistant came in and she said, "Oh, Professor Raymond Dart is on the phone for you." And I thought, of course, this was one of my colleagues playing a joke on me. And it was. And I heard this voice and he said, "This is Raymond Dart, and I want to congratulate you on your very extraordinary discovery." And I did, in fact, get an opportunity to spend time with him, and it was wonderful. We were both 31 years old when those discoveries happened. He was not, when I talked to him, he wasn't 31, but he was 31 when he made that discovery. And of course, in the 1950s and 1960s, the arena of discovery switched very dramatically to eastern Africa, where the well-known Leakey family, particularly the late Louis and Mary Leakey, were working at at that time it was called Olduvai Gorge. It's called Oldupai Gorge these days. But that's right on the edge of the Serengeti. It is a dissected set of sediments on the edge of the Serengeti. And it was where in 1959 they found this skull you see in the lower left-hand corner of a very robust Australopithecus. It wasn't like that Australopithecus africanus we just saw. It had a crest on the top of its head. It had all sorts of specializations for mastication and so on. And it opened up a rather major new arena for discovery, and that was the Great Rift Valley in eastern Africa. In the late 1960s, a colleague of mine, Maurice Tayeb, who was pictured in this Science magazine today, was a geologist, and he was working in Ethiopia in what is known as the Afar Triangle, where he was undertaking geological research on the general nature of the sediments and rocks and so on. And during the course of his work, he found areas that were very fossil rich. I met him in Paris, and we spoke about this, and he showed me photographs. And what was so exciting about those photographs was not just how beautiful the place was, but that the fossils that were being found, particularly the pigs and the elephants, fossil pigs and fossil elephants, suggested that these sediments were older than 3 million years. And at that point, for instance, Olduvai Gorge is about 1.8 million. The 3 million year barrier had not been breached. And I felt if we could find human ancestor fossils of that antiquity, it might open up a significantly new perspective for us on early hominin evolution. And the one place, oh yes, oh good, here we go. So the site that we decided to work on was a site called Hadar. It's a local place name for the Afar people who lived there. And in 1973, we formed an international multidisciplinary team to work in this area and to systematically search for fossils of our human ancestor. And here you see one of the first views I saw of these geological deposits. And to somebody who is a paleoanthropologist like myself, and there are many in the audience this evening, this was nirvana. I mean, this was really the El Dorado of paleoanthropology. It had beautiful stratified sediments. It had some of the lighter layers in there that were volcanic ashes that could be used to date those sediments. We could tell how old the fossils were. And much of many of these sediments were laid down in a lake where it was very quiet. So these fossils would float down to the bottom and stay articulated. So we had chances of finding more complete specimens. And we formed an organization and systematically began to work this area. So here's an aerial view I took a number of years ago to show you the site of Hadar, where we camp out for 2.5, sometimes 3 months a year. And I'm sure you've all spotted our camp, which is that little dot there. There's no CBS nearby, so you have to bring everything that you need, because it's a long way out if you need something. And we began to systematically, as I said, survey these deposits. And here's a shot of what Camp Hadar looks like. Some of these tents, for example, you see, this is a kitchen tent, this is a eating tent, there's a work tent there, there's a kitchen in the background, and so on, and various places where we slept in our tents for 2.5 and 3 months. So when people ask me now, Don, would you like to go camping on the weekend? Well, I think 3 months a year or 2.5 months a year for 10 years is enough. We had a permanent source of water, which you see there. Whoops, pushed the wrong button. There we are, permanent source of water. That was the river, the Awash River. And just in January, we spent 2 nights sleeping in this area with a group of people, some from Arizona and other places, to go back to the actual spot where Lucy first was discovered. This is the size of some of our teams. These are international teams of scientists, French and European and Ethiopian. And we would organize the fall, usually October, November, and December, part of September, to be there. We had archaeologists, we had people who studied fossil pollen, we had people who were searching for stone tools, people who were looking for fossils, and so on. And it really is, as Johannes can attest, he's just come back from doing field work in Ethiopia, that there is a special camaraderie that develops when you're in the field with people eating breakfast, lunch, and dinner, and doing the same thing, that you're all interested in trying to understand that big question of where did we come from, how did we get here, how many species lived in the past, what sort of environment did they live in, did they make tools or did they not make tools? And every day at breakfast, lunch, and supper, we would sit around, and geologists and anthropologists and others would talk together about trying to add to understanding this incredible question. And our return trip was especially poignant because I got to see some of the local people we had worked with many years ago who were still there and still deeply interested in this. And there is still a great deal to be found in Ethiopia, particularly the Afar Triangle, and I'm sure that discoveries will continue to be made here. The big question, where to look? You know, there's no sign out there that says dig here. You know, Lucy died and is buried there. So how do you find these things? When you stand and look from a perspective like this, it's daunting. I mean, you just can't strike out and, you know, do a random walk. You've got to systematically cover this ground with search teams like you see here. And it's called foot survey because you're walking from just after breakfast, very early in the morning, coming back around noon, having lunch, maybe having found something, maybe not. I worked in southern Ethiopia 3 years going, and I never found a fossil hominin ancestor there. But you find a huge variety of animals, fossilized animals, that tell you and give you insights into the kind of world that Australopithecus lived in. And the only way to find these is to go out and hone your senses and look and walk and walk and look. Sometimes imagine finding something like this. What you're looking at here is a little chunk of lower jaw or mandible and a beautiful little molar here. That's one of our lower molars, so you know that's part of a lower jaw. And the collector who found this was able to discern that as something unique and important from standing height, even though it was kind of hidden among all of these pebbles. Other times, and people, you know, one of the things that bothers me the most about journalists is they always say, oh, well, when Don stumbled across the fossil. Well, you don't stumble across that, but you might stumble across something like that. This is a virtually complete 3.4 million year old elephant skull. All of you would know that. And it's in a beach sand where it's being excavated, and it's there, it died there, and it was buried there, and there it lay for 3.4 million years. So a great diversity in non-human fossils. We were talking about this just before I came out to speak to you this evening. Of course, I love Lucy. There's no question about that. But what was the fossil that really I remember with such incredible dearness or nearness or glee, and that is the discovery of this fossil knee. So this is what you have. You have your thigh bone. Whoops, just 80 years old here. Can't press the right button. So this is your thigh bone here going up with the shaft of the femur, and this is the top of the shin bone. And I knew that it was from a human ancestor. How would we know that? Well, we know that because when you compare the way the thigh bone rises upwards in a chimpanzee that walks on 4 legs, of course, you see over here that it's essentially perpendicular to the horizontal. But we, and that's all of you in the audience, have a femur that rises at an angle to the horizontal. And that is exactly what we see in this 3.4 million year old knee joint. In fact, when I brought it back to the United States, there were no facilities in those days, but over the years, scholars who have worked in Ethiopia and continue to work there have built laboratories. The Ethiopian government has taken deep interest in the origins of humankind and has invested in manpower, invested in laboratories, and so on for people to travel to Ethiopia and work. But I had it on loan for 5 years, and when I brought it home, the first person I showed it to was an orthopedic surgeon. And he looked at it, and he said, boy, he says, it's so tiny, it's very small. And he said, but it's exactly like the kinds of knees that we replace. It had all of the detailed anatomy of upright walking. And if you go back and read Darwin, and in the early literature, one of the cardinal features, as I said, of being human was walking upright. So we knew this was from a human ancestor, but we didn't know who that ancestor was. Was it like the one that Dart found in South Africa, or was it something new? And that's why we continued to go back over the years, and in 1974, we launched an expedition, a little bit larger, a little better funded, and we were out surveying. I was with one of my graduate students, Tom Gray, and we had been out in this area, as some of you who were there recently will recognize. And just about here, I happened to look over my right shoulder, and here was this little piece of bone, and just where that yellow dot is. And as you see, me much thinner in the old days back there, and of course, who's doing all the work? The graduate student, you see. We're collecting the very first specimens and putting in little flags where they were found with a number on it and a description of what it was. And the first bone that we found, as I said, was this little bone here. That's the one that allows you to flex and extend your arm. And we looked up the slope, and we saw pieces of a leg bone, we saw pieces of a jaw, we saw little fragments of a skull, and we realized that this was part of an individual. Normally, as I said, we're very happy if we find something like the knee joint or a nice jaw or a piece of a leg bone or something. But here we were assembling part of a skeleton, which meant that we could get a real glimpse into the anatomy of the individual and understand perhaps how this was related to other kinds of early hominins like Australopithecus. And she ultimately was given, with the other fossils, we now have close to 500, maybe 600 specimens of this species. Our species is Homo sapiens, right? Supposedly intelligent man and woman. But it belonged in a species. And we decided that it was Australopithecus, and we decided it should be named after the Afar people in the Afar region of Ethiopia. And in 1978, it was given the name Australopithecus afarensis. And the geological dating, geologists were able to date these various horizons of volcanic ash, for example, that she was about 3.2 million years old. I didn't know when we first found her that she was going to be a new species. I didn't know that we would be able to precisely date her until much later, when geologists had figured out all of the geological strata. And she was we were celebrating in camp, obviously. People ask me all the time, how did she get her name? How did you know? Some little middle school student wrote in recently and said, how'd you know her name was Lucy? So we were celebrating in camp, as one would do, and and still am a great Beatles fan, and Sgt. Pepper's Lonely Hearts Club Band was playing, and Lucy in the Sky with Diamonds was playing. And a member of the expedition said, you really think it's a female? And I said, yes. I said, the length of her thigh bone is only the length of a ruler, 12 inches, like most of us, and all of ours are much longer than that. So she was probably very short. So then another student said, well, you think she was a child? She hadn't grown up? Well, we looked at her teeth. Her wisdom teeth were erupted in her lower jaw. And the growth plates at the ends of the long bones were fused, so we knew she was a full adult. And reconstructing her stature, she's only 3.5 feet tall. And she was a mature adult. So this other member of the expedition says, well, why don't you call her Lucy? And the name stuck. I said, well, I'm a PhD, I just got my doctorate at the University of Chicago. I've got to come up with some clever name for this. But it was too late. Once the name was uttered that evening, the next morning at breakfast, Don, are we going to go back to the Lucy site? Do you think we'll find more of Lucy's skull? How old do you think Lucy was when she died? And there was no way of changing that. And of course, she is known by Lucy worldwide today. She is one of many of the extraordinary fossils that reside today in the National Museum of Ethiopia in Addis Ababa, and was celebrated a number of years ago when the government decided to issue a commemorative stamp, which you see, I think it was 1985. And what was so interesting about that was that one of the people from the Ministry of Culture, under which we get our permits, came to visit soon after she was discovered. And he pointed out something very important. He said, she was found in Ethiopia. She needs an Ethiopian name. So I said, well, what should we call her? My Amharic is not very good. So he said, why don't we call her Dinkinesh? And I said, oh, okay. What's Dinkinesh mean? And he said, it means you are wonderful. You are marvelous. And she is known in Ethiopia both as Lucy and as Dinkinesh, as this very wonderful fossil, and is for many people the best known fossil discovery on our human family tree, as you will read in the journal Science, I hope. Here I am, much younger. This is a picture the first time I've ever shown this picture. It just came into my hands from a young woman who was on the expedition, Bobby Brown. I don't know if she's here tonight, but she will be here tomorrow evening. And we're getting near the end of excavation on this slope. But as you can see, we didn't have to dig very deep. And if we had not found her that season, in November of 1974, and a major torrential rainstorm had come through, almost all of those bones would have been washed over a cliff out on the right, outside of this picture, and probably lost forever. So it was fortuitous that we were there that day, and I was looking in the right place. Today, if you visit Ethiopia, you can actually go to the Afar region. There are tourist companies that take people there, and more people are going to see the original site. The local Afar people are very proud of her because she was found in their part of the world, and for some of them, they have the interpretation that she was the first human, and therefore we're all descended from the Afar tribe, which I find, as an anthropologist, most interesting. And there is a plinth that is erected there in Amharic, Afar, and English, commemorating that discovery in 1974. One of the great controversies, or controversies, as others would say, that erupted out of this was we asserted that she was walking fully upright, that she was fully upright walking like we are. But she still had a small brain. Her brain was about the size of a cup and a half or 2 cups of morning coffee. Our brains are about 6 times that size, of 6 cups of coffee. And so the big discussion was she really fully upright? And some people had her still living and climbing in trees a great deal. And you can see her pelvis, which you're all sitting on, in the middle. And there's a chimpanzee pelvis on the right and a modern human pelvis on the left. And you don't have to be a PhD to say, now, does pelvis A in the middle resemble pelvis B on the left more, or the pelvis C on the right? So this was an enormous series of articles have been written about this, whether or not she was upright. I think that's incredibly convincing evidence that indeed the way she got around was on 2 feet. And here is a reconstruction, the one that appears on the Science cover today. And we have a replica like this. She's fleshed out and fancifully put some hair on her and so on, but she's walking upright. She doesn't have a large, divergent, grasping toe. She wasn't climbing in the trees much. Or if she was, perhaps it was only for sleeping at night. And at the Institute of Human Origins that Johannes mentioned, the door is always open. And you're invited to come and see this in 3 dimensions. It was done by a wonderful paleo artist by the name of John Gurchi. And she is available to anybody who would like to see her. Well, what's really exciting about that period of life is controversy is really good for science. Because it forces us to ask different kinds of questions, to search in different places, to hypothesize quite differently, and so on. And Mary Leakey, the late Mary Leakey, came to visit us in Ethiopia. And the day she left, the next day we went out and found Lucy. Unfortunately, she was not there for the discovery. But over the years, she could see that the fossils that we were finding were in terms of pig evolution or elephant evolution or rhino evolution or whatever, quite primitive, quite old, that they came from a very distant past, more than 3 million years. And she was reminded of a site that she and her husband had visited in the 1930s called Laitoli in Tanzania. That's about 500,000 years older than Lucy. And she decided to go back to that site and see if perhaps there were any fossils, because they didn't find but one fossil they misidentified back in the 30s, but they really didn't find any convincing evidence of fossil humans at the site. And during the revisit, just after in the 1970s, they began to find teeth and jaws. And while they were searching for these, some of the surveyors, some of the people who were working on the expedition, noticed that there was an imprint in the volcanic ash that they were excavating. And it looked like a heel print that was made by a human, which, you know, people said, you must be crazy. You think that people are walking here 3.7 million years ago? And it turns out that there was a volcanic eruption in the background, and this volcanic ash came down like a snowfall and covered the surface of the ground. There was a light rain, because you can see raindrops in it. Amazing. And you can see imprints of birds' feet, and elephant feet, and baboon feet. And when they lifted the volcanic ash, they saw that that was indeed a heel print of a human foot. And the mandibles that they were finding, the lower jaws, were identical to the ones we were finding at Hadar. So this had to be the same species. And taking a close look at the imprint of that foot in the 3.7 million year old volcanic ash is the kind of footprint that we all leave when we walk on a beach, and the beach is moist. Well, just after this eruption, there was another eruption, and that sealed that horizon and preserved it for 3.7 million years. And you can see in the details of this foot that there's a strong heel strike. Think about it as you walk. There is a strong toe off. That's your greater toe that we use to propel ourselves forward. And there's an arch this way in the foot. And there's no gap between the lateral toes and the great toe. So here, as far as I'm concerned, is the smoking gun that Lucy's species was walking upright. The only thing better would be if we had been visited 3.7 million years ago by someone from outer space, right? And they were on vacation and shot video of these creatures. I don't have a lot of faith in that one, but anyway. Lucy has become very popular. You've all had Tazo tea of different kinds, and this says some say all humans descended from a single African primate called Lucy. If it's true, she probably enjoyed taking a break from the kids with a soothing Tazo red bush tea. So we see here, New York Times crossword puzzle, human ancestor, 4 letters, ends in Y. There's a Lucy bakery in Addis Ababa. There's a Lucy insurance company. There's a Lucy taxi service. The national women's soccer team is called the Lucy team. It's quite amazing. And one of my favorite cartoons of all is this one at a paleo cocktail party being introduced. Not the Lucy. And of course, not only has she been important for the average person's understanding of how we came to be human, but she and the hundreds and hundreds of other specimens of her species that have been found have delivered an enormous amount of data for understanding details of locomotion, details of length of maturation, times of death, and so on, that we never would have had before. And with all of those specimens associated with a single species, it's come to be the single reference collection for understanding human variation in this time range between 3 and 4 million years. So as I said, there are hundreds of specimens. Here you see a collection of jaws in my old lab in Cleveland, but this table would be twice this size or more if we did this with all of the specimens we know of that belong in her species. One of the things that was missing was, what did she really look like? We didn't have a skull. Lucy's face had disappeared. It had been washed away by earlier rainstorms. These bones are fairly fragile here. And we had parts of skulls, but we really didn't know what she looked like. And we wanted to know what she looked like. And skulls, there we go. Skulls, if you look around, how do you identify the neighbor sitting next to you? Not by, you don't look at their thigh bone first or their foot, you look at their head. And that's the same case for understanding variation in fossil species. That's where much of the diagnostic anatomy is based. So in the 90s, we resumed exploration in this area and found finally a fairly complete male and fairly complete female skull of the species, which has allowed paleo artists to make much more appropriate reconstructions of what these creatures look like. They certainly weren't living a solitary life. In 1975, the year after Lucy's discovery, there was a collection of fossils found from a locality which is called the First Family. And it's called that because there are remains mixed in one geological horizon of infants, juveniles, males, and females. And it appears that this was a troop of afarenses living together 3.2 million years ago, and for some unknown reason died and were buried together in this one horizon. So we know that they were certainly living in groups, probably not totally different from what we see in contemporary chimpanzees. And this reconstruction was done by J. Maternus, another one of the leading paleo artists. And it shows a mixed group of males and females and offspring out collecting fruit. And we know those fruit trees were there because there is a person in France who is a palynologist, and she studies pollen, and she studies fossil pollen. Yes, pollen also fossilizes. So she takes samples of these sediments back to the lab, cleans up the samples, and can take out the pollen grains and compare them to living species. So we know that they lived in some instances in forests like this, but we also, we don't have any sound on this, do we? We forgot to do that. Well, anyway, so, what did Lucy look like? And in the early 1990s, I hosted a three-part NOVA series for PBS, and we recreated an animatronic to look like Lucy. And I suggested that why might she not be termiting like contemporary chimpanzees do? And here you see she's using a stick, she's wet it, and termites are attracted to those. And she's pulling these termites out of this termite mound, which would have been a source of, as I said, very rich protein for these. And it shows a certain sense of really understanding how this goes with that, and this will produce something. And here you see the exact termites that you would find in that site, brought into the studio to film. And maybe she was beginning to have a sense of awareness of the world around her. Recent work, partly with Bill Kimbel in one of the articles that he published most recently, there's a 20% increase in the average size of the brains for afarensis over what we see for an average chimpanzee. So this is speculation, but I think it's certainly something to consider. Another good friend of ours is in Spain, and this is Mauricio Anton, who has recreated this wonderful scene. You see over here a couple of afarensis, and that shows you what we call sexual dimorphism, the two different sizes, the larger size of a male and the smaller size of a female, wandering around in this sort of landscape. They were predominantly, we believe, vegetarians, but in the case of Lucy, we don't know why she died, but there is one little puncture mark in her pelvis that you can find with a little hand lens. And she was found near permanent water. And in that stratum, there were round eggs, which were turtle eggs, and the eggs like you have at home in your fridge, which are crocodile eggs. And maybe she was down gathering crocodile turtle eggs and unawares of a crocodile that was nearby may have killed her and dragged her into the lake. So these are all wonderful insights into the world she lived in. And the other thing we must remember when we go back and try to reconstruct their behavior in the world they lived in, that they were an integral part of the natural world, right? They were just like any other creature that was living at that time. They were fully integrated within that natural world. So you're looking at a creature that through natural selection became adapted to that particular world. I wanted to bring this to your attention, and you will see here ASU is mentioned again. And Arizona State University, under Michael Crow's leadership, has become an extraordinary university. And I was in all places. I was in Bhutan, and I received an email from a senior researcher at NASA. And I thought, why is somebody from NASA writing me? And he said that he was enthralled with the idea that Lucy gave us so many new insights into understanding human origins that he wanted to name a NASA mission, a billion-dollar mission, after Lucy and call it the Lucy mission. And my wife Robin and I went down to see the launch of this rocket. Quite incredible. You see it in the background there. It's gone out to the Trojan asteroids, which are connected, are in Jupiter's orbit, 300 million miles, okay? It's quite a ways. At about 10,000 miles an hour, it recently went by a asteroid, not in the asteroid belt, but in Jupiter's orbit, on November 1st of last year, at 10,000 miles an hour, 300 million miles out there, within about something like 600 feet or something like that, and took pictures of an object that was about the size of a school bus. And it's trying to understand the origins of our solar system. And the rationale for this particular NASA mission was, as Lucy taught us about our origins, this mission will teach us about the origins of our solar system. And what's really interesting is that particular asteroid, and of course all these asteroids get names, and it's hard to read, but it's gone by an asteroid which is called Dinkinesh. It's an amazing story. Next year, 2025, it will be going by an asteroid that was named after me, and we'll be calibrating its instruments, one of which was built and designed by people right here at Arizona State University. So it's really something to ponder, that here was an unknown individual 3.2 million years ago, walking the African landscape, dies, fossilized, rediscovered, and now has influenced a completely different science, and is out there trying to help us understand how our solar system came to be. As all of you know, as Pliny the Elder wrote, sempre aliquid nove, out of ex-Africa, always something new out of Africa. And I wanted to mention two of my colleagues at the Institute of Human Origins, because these discoveries are continuing to be made. This is Kay Reed, who's with us tonight, and she had with her a young Ethiopian scholar who did his doctorate here at Arizona State University at Institute of Human Origins, and he discovered this mandible, this little piece of jaw, which you see here, at a site that was about 50 or so kilometers northeast of where Lucy was found. And what is extraordinary about this is, first of all, it's 2.8 million years old. Okay, almost 3 million years, but 2.8 million. And with the detailed work that, under the leadership largely of Bill Kimbel, it was noticed that there are portions of the front of, yeah, there goes that wandering finger again. The front part looks very much like Afarensis' jaw. It's very sloping and ape-like. But when you get to the back end of this, that's the wisdom tooth you see right there, there are differences. And the shape of those teeth are more elongated, long and narrow. And they're more like genus Homo. And we think that this is the earliest evidence thus far of our own genus Homo, and that it shows the features of its ancestor and of its descendant. So this is quite a remarkable discovery, and there is still more news to come out of this very important Lady Gararu site. And Johannes, who gave me such a lovely introduction, is now director of the Institute of Human Origins. He was born in Ethiopia. He developed a real interest in this. He was educated at the University of California at Berkeley for his doctorate. And he found Lucy's ancestor, I think. There's a lot of discussion about that coming up, I'm sure, that belonged to a different species We give these different species names, and it was called Australopithecus annamensis. And it lived anywhere between 3.8 and 4.2 million years ago, which is, when you look at that, that's 400,000 years. That's quite a bit of time for that species, and may have been the ancestor to Australopithecus afarensis. And he has just come back from the field, and I'm sure we'll have more interesting surprises. So when I initially left graduate school, I say 1970 is the year I entered the field because it was the first year I went to Africa. My dream came true. I landed in the middle of June in Nairobi of 1970 and was led to an expedition in southern Ethiopia. Dart's Australopithecus africanus, which you see here, was thought to be the common ancestor to these two branches, one that led to other Australopithecus species, and one that led to our own lineage through species like Homo habilis, Homo erectus, and ultimately to us, Homo sapiens. And that was the state of the art. There were Neanderthals also known from that time period, but there weren't very many species, obviously. And in addition to that, there was a major time gap between Lucy afarensis, who died out about 3 million years ago, and the presence of Homo and this highly evolved and highly adapted form called Australopithecus or Paranthropus boisei. And in an article which was published in Science way back when, my colleague and I suggested that afarensis was the common ancestor to these two branches on the human family tree, which was pretty gutsy. And it was a really bold suggestion. Why? Because there were no fossils between 2 and 3 million years. So it was easy to criticize Don in those days. Well, subsequent to that, we have an ancestor, which is typified by this beautiful skull that Johannes' team found. We found I didn't find this, but Richard Leakey's team found Australopithecus aethiopicus at 2.5 million between afarensis and boisei. And another new lineage was discovered, which was called Australopithecus gari. But until recently, the branch that led to ourselves has been pretty empty. Well, fortunately, in the 1990s, a upper jaw, which is given this very unaffectionate name, AL666, looks like the one that your dentist peers into when he looks in your mouth. Doesn't have straight sides. It doesn't have a very long distance between the front and the back of your mouth. It's not shaped like an ape's jaw. It's shaped like a human jaw. And that is about 2.4 million years old. And most recently, Kay Reed's team found this specimen at Lady Gararu, which helps us understand in somewhat better detail how afarensis may have been an ancestor of these two lineages. These are hypotheses. These are suggestions based on the current data, and I am certain that they will change, as I've already discussed with Johannes on our trip to Ethiopia. But you see how much richer the tree has become. We had before, as I said, about 7 species. Now there are about 22 species of humans. I won't be talking about Neanderthals and Floresiensis and all of these other things. But the human family tree is fairly species rich. And I've also suggested most recently that it was probably an ancestor to those South African forms, Australopithecus africanus and Australopithecus, or as some say, Paranthropus robustus. So this is obviously a work in progress. And there will be, I'm certain, on our Saturday, during our Saturday symposium, more discussion about the relationships between our ancestors. So before I close, I want to invite all of you who have not been to go that short distance and come to the Rob and Melanie Walton Center for Planetary Health. They donated very generously to the development of this building, an extraordinary building. Some of you must have driven by this at the corner of Rural and University. And you can find out much more about the Institute, the events we're having, discoveries that are being made. We have a brand new, phenomenal website, which was launched fairly recently. You can go to iho.asu.edu, and it will take you to our website, and you can explore that at your leisure. But if you want to visit, there's a parking garage on this side of University Avenue, so you don't have to cross that dangerous intersection, and take the bridge right across to the second floor of this building, where the Institute of Human Origins is actually located. So I invite you to do that. Now, people often ask me, do I ever hear much from Lucy these days? And I came across a wonderful gift that was given to me many years ago, like 30 years ago. Oh, to be 50 again. So thank you so much for listening this evening, and I hope being somewhat enriched by a better understanding of where we've come from. And the take-home messages are, of course, that for most of the 19th century and largely a large part of the 20th century, Europe was considered the finishing school for humanity. That's where they painted caves. That's where Cro-Magnon lived. That's where they're making sophisticated tools and so on. Nothing ever important happens in Africa. Well, we now know that that little abbreviated family tree I showed you, no matter what branch you grasp on that tree, the roots all lead back to Africa. I think it's interesting with the revolution in genetics. We see that all of us carry within us primal genes that first evolved in Africa, so that we're all united by our past, and Africa was the crucible where natural selection crafted us to be who we are today. And if we have a common origin, a common beginning, we as a species, the most intelligent species we know of in the universe, right? They may be out there, but we don't know where they are. But we are the most intelligent species, and it is up to us. The future of this planet, the future of this species and our fellow travelers is in our hands. And I am hopeful that our species will make the right decisions so that we, the descendants of ours, will look back and appreciate what we've done rather than look back and be angry. Thank you very much. Thank you. Thank you. Thanks. Thanks very much. Thank you. Thank you. You have house lights up? Oh, thank you for being such wonderful listeners. And we have one microphone over here. If people have questions, I don't even know what time it is. Oh, it's a little after 8. That was about the right length, I guess, I hope. And I know where my colleagues are, so when I see them going up there, I'm not going to let them ask questions. Yeah, Arn.
Is this on at all? No. I don't have a question, but if you feel like you know us well enough, you are invited to our house.
Well, any evidence that Lucy gave birth? We don't know. The baby's brain would have been very, very small, so it didn't affect the pelvis as in the ways that our larger brain species, Homo sapiens, affects the the shape of the pelvis, and also, well, the shape and size of the opening that the fetus has to pass through. So we don't know if she gave birth to infants. There is a beautiful baby skull and partial skeleton found of her species by another Ethiopian colleague of ours, Zoresanai Alamseged, which is about 3.3 million. So we certainly know they had babies. But we don't know if Lucy herself did. Okay, well, I wish you all a nice evening, and again, thank you so much for coming. Thank you. Thanks so much.